Yep. Hello, everyone. You should be seeing this. So, yeah, hello, everyone. Good morning, good evening, wherever you are. So, this is the first session that we're doing in the track that would eventually where we talk about AI and ML. And since we had quite a lot of beginners on the call, what we have decided is essentially we'll start with the basics of Python programming, right? And then we'll eventually sort of take it up by sort of like going into more advanced topics and finally giving you the ability to be able to build machine learning models as well. So we're starting with the basics of Python programming, and that's what today's class and the next few classes would be about. So you get a sense of how Python works, how you can use Python to build programs, and overall how Python really is useful to sort of like do what you want to do for AI/ML. That's the crux of what we're trying to arrive at today here. We have a few people here, right? So again, based on what I'm hearing, like most of you are beginners, so that's why we are sort of starting maybe at like slowly, and we'll slowly ramp up the pace as we go once we make sure that everyone's on the same page. All right, that's the plan here. So yeah, today it's the introductory class. I'm calling it class 0, and this again is a programming convention. So in programming, let's say in all modern programming, we always start counting from 0. Like in general, whenever you start counting, you say 1, 2, 3, 4, right? But in programming, we always start from 0, and that's the convention we are using here. Since it's the introductory class, we are sort of starting with class 0. And if anyone's familiar with C programming language, this convention started from there. So all modern languages pretty much are like descendants in spirit from the C programming language back in the 1970s and 80s. So that started this convention of counting from 0. So every language after that, Java, C++, Python, etc., they all do the same thing. So everything count from 0. Okay, so that's something to keep in mind. And so maybe just a quick question to see the overall like level of the folks we have over here. So how many of you here have programmed in some other language till now? Doesn't have to be Python, but any other programming language. Can I get maybe a yes or a no, for example? Okay, I see one person saying they have. All right. And which programming language is that? This is Santoshi, right?
Yeah, it's Python.
Python. Okay. All right. Great. What about others? Does anyone have experience with anything like could be Java, JavaScript, or anything else?
C and Python.
Python. Okay. Wonderful.
I have some experience with Python.
Okay. All right. We have a couple of folks saying Python. Then that's good. Anyone familiar with maybe some of the other languages, say C, C++,
Yes.
say Java,
SQL,
for example?
PLSQL.
Okay. All right. Wonderful. Okay, I think we have maybe a little mixed audience here. So a couple of folks have some experience with Python, and I'm guessing others do not have, or maybe have very basic understanding of what programming is about. So maybe we'll start with just a little refresher on what programming is. So others who are familiar, maybe like this could be a like a roundup session in that sense. So there can be quite a lot of definitions of what programming is about, right? Because all of these are programming languages. So what programming is something important to understand. My definition of this is basically shifting the perspective of the users, right? The way I see programming is basically taking a user from being an active consumer to making them an active producer. What do I mean by that is, let's say, I mean, all of us have smartphones these days, right? So whenever you open something, you're actively consuming any of the app that you have, whether it's WhatsApp like Instagram, Facebook, whatever, YouTube, etc. So you're actively consuming the application. So that's what a typical user is. But a programmer is somebody that goes behind that, right? So you are the one actually building those applications, right? Whether it's the apps on your phone, the apps on your desktop, or whether it's websites, it could be anything. But um, for me, programming is basically all about shifting the person from like in being in front of the screen to being behind the screen. Right? So you are essentially the one giving out these services to the world. So that's what programming enables you to do. In short, programming allows you to control the computer in a way that you want it to. Right? That's the idea. Because hardware can be anything. Like you can have like the most powerful computer, with like the latest CPU, the latest GPU, but without software, it can't do anything. And software is written by programmers, right? So programming is all about making the hardware be usable. Okay, so that's what it is. And generally, we say programming is about automation, right? So Python obviously is one big example of that. So anything you want to do, instead of having to do it 1,000 times manually, you automate that through programming and you do it like any number of times you want, right? And whenever we say a program, uh, what we described it as being the ability to make a computer do what you want. So this is essentially a series of instructions, right? So you tell the computer, you want to do a few things, and then it does that in that particular order. So a program is nothing but a series of instructions, essentially, right? So, like, I mean, a common example that sort of gets compared is like cooking. So whenever you want to cook something, you have to follow a set of instructions, and you end up with something that you could hopefully eat. It's the same idea with programming. You follow a set of instructions, and then what you get is something you could use to control the computer in some fashion. All right. So that's what programming is. And let's sort of start talking about Python, right? Obviously, you are here trying to learn about Python. So, which means that Python is something you're familiar with. And in fact, Python is one of the most popular languages out there. So I've put a couple of stats here. These are language surveys done across the world every year, and they get updated very regularly. So in most language studies and statistics, Python always stays in the top, or at least in the top three. And a couple of them I've tried to pick. So PyPL statistics is basically like looking up based on the Google search results. So how often is a programming language looked up, searched for? And there is another called TIOB, which sort of looks at multiple places. How many programming jobs are there in the world? How many people are actively learning it, things like that. And then there is GitHub, where all the source code generally just gets kept. So in most of them, you can see Python is like one or two in all these three. And in other programming language studies as well, it would generally be in the top three. So that's the reason, like everyone sort of like looking to Python these days. And the reason Python has become so popular these days, right? Like I've tried to sort of summarize it a few things over here, but one of the main advantages with Python compared to say a few other languages is it's generally considered very easy to learn, meaning it doesn't have a lot of barriers of entry that some of the other programming languages have. So if you know maybe even very little programming or even no programming, Python is probably like the best way to get started, to familiarize yourself and sort of indulge yourself into the world of programming. Okay. And also another reason for its popularity is because you could do anything you want with Python, right? It's not something you could say with other languages. Every language has their niche areas. So for example, Java, you could build applications, but maybe that's about it. But Python, on the other hand, because of its flexibility, you could do anything you want that you could do with any other language in Python, right? So a few areas that Python has become really popular. Obviously, data science and machine learning, Python is pretty much the go-to language in that field. So whether you are trying to build data visualization, right, like beautiful charts and reports, or you are doing recommendations, AI, etc. All of these, the primary source that anyone goes towards is Python in this field. And similarly, you could build websites and web applications with Python. Not currently, but YouTube used to run entirely on Python. Now they have switched to Python and JavaScript. Instagram still uses Python to this day. There are a lot of frameworks very popular through which you could easily build websites and web applications. And you can build GUIs. So GUIs are basically front ends, right? For building applications, you could build games. You could do a lot of automations, So Python, pretty much anything you could imagine a programming language could do, Python can do that. That's the reason, because it's so flexible, it has become so popular, and also because it's so easy to get started with, it made it even more popular. So a little more about Python itself, right? So we call Python a cross-platform language. What we mean by that is, previously the languages that we had, let's say C and C++, if you're familiar with that, if you write your code on a Windows computer, the same code wouldn't work on if you go to a Mac or Linux, right? Imagine if you had this situation where maybe you're giving a presentation, or maybe you have to you're writing a Word document, and if you go from your computer, which is a Windows, to a friend's computer, which is a Mac, you have to rewrite everything or redo everything. That wouldn't be good, right? So previously it used to be that none of the programming languages were cross-platform, meaning if you have to go from one operating system to another operating system, you have to rewrite everything, right? But modern languages are cross-platform, meaning for those who are familiar with Java, for example, would also be cross-platform, in the sense that the code you write in Windows can be ported over to Linux or Mac, and it would run exactly the same. So you don't have to rewrite for every machine there exists. Okay, that's what we mean by cross-platform. It is compatible across all operating systems. And we also call it general purpose programming language, meaning you could do anything you want generally with that programming language. In contrast, there are special programming languages which are really useful in very few areas. But Python, on the other hand, is a general purpose language. So you could do anything you want, and it can be used anywhere you want. Okay. And Python is an interpreted language, meaning, again, there are two types of programming languages depending on how they work. So again, I'm sort of like referring back to C or Java. I'm hoping some of you are familiar with it. That's what are the other popular languages, right? So if you look at C or C++ or Java, we call them as compiled languages. What we mean by that is there are 3 steps whenever you want to run a program. So you write your code, but before you can actually run it and make your computer do something, there is this additional step in the middle called compilation. Okay, so compilation is sort of like, you can imagine it as being translation layer, where you write your code in English, but that gets converted to a language that the computer can understand, right? So compilation is sort of like the translation layer. So in other languages, you have this additional layer in the middle, which is called compilation. So you write your code, but before you can run it, you have this compilation step in the middle. But Python doesn't have this. We call Python an interpreted language, which means that you write your code and you run it. There is no additional step in the middle. That running step is called as interpretation. So otherwise you have compilation and running, but in Python it's just interpretation as one step. Okay, so that is another difference compared to some other languages. And like we said, because it's cross-platform, it can run basically on any operating system you can think of. And this was created back in the late 80s. So this is the guy who made Python, so Guido van Rossum. So he's very popular in the Python community, obviously, and he's still actively working on the language. So he started building Python back in the late 80s, and the first release of the language happened in 1991. Okay, so this is quite old. And for those who are familiar, Java came in 94, 95. So Python is technically older than Java. Okay, so yeah, it's one of the older languages that exist over today. C and C++ are obviously older, but compared to Java, JavaScript, Python is the older language. All right. Yeah, maybe I know this is all generic statistics and facts, but any questions so far? Are you able to follow All right, so far. Okay, all right, then I'll take that as a yes. So next, let's compare Python to one other popular language, which is Java, right? Again, I'm comparing Java because that's the most popular language you will see everywhere. So Java, JavaScript sort of goes together in this area. So the main reason, again, we sort of said that Python is obviously more popular in general, right? And in terms of comparison, we say Java is verbose, meaning to do something very small, you have to generally write a lot more code, a lot more lines of text in Java compared to Python. Right? So Python is generally simpler and compact. That is, you can sort of like put a lot of information together like in a single line in Python. Okay, so that's something again you will see with a couple of examples that I'll show you. Another thing to keep track of, which is why Java is generally a little more favored in the industry than Python when you're building applications, is because Java is highly backwards compatible. So backwards compatibility is something that is really important. What we mean by that is, uh, so let's say for those familiar, there is a version of Java called 1.8. Right? So Java 1.8. This came way back in 2014, I think. So Java 1.8. So if when the language came, so Java 1.8 was new, right? So you start writing code in 1.8, and generally in most languages, what happens is you have what is called as a support. So whenever a new version of the language comes, after a couple of years, you won't support that language anymore. Right? So everyone sort of understands like the term of software updates. But Java is highly backwards compatible. What you mean by that is Java 1.8, which came back in 2014, is officially supported all the way to 2030. So 16 years of support. What we mean by that is essentially, even if you never change your code, whatever you wrote in 2014, you could still run that code for 16 whole years till 2030 and never have to look back, which can be very attractive for companies because you have to write your code only once and you don't have to like keep changing anything because you could just keep running the same thing as long as everything is working for like 10-15 years depending on the language, right? But Python on the other hand doesn't have that long compatibility. I mean, it is compatible, but let's say maybe for a year, 2 years, 3 years generally. So whenever Python goes from one version to another version, so especially Python 2 to Python 3 was a big divide. So the currently we use Python 3, which is the version of Python that we will study as well. But when Python 2 to Python 3, the switch happened, there was a lot of issues because they were two completely different languages almost. So whatever you wrote in Python 2 wouldn't work in Python 3, and what you write in Python 3 wouldn't work in Python 2. So that could be a problem sometimes when you want to make sure you don't want to invest too much time just changing your code because the language changed, right? So that's why we say Java is a little more favored in the industry, but that is changing slowly these days because Python is also trying to add more backwards compatibility, but still nowhere near as Java. All right. And another thing, this is something you'll probably hear quite a bit when you work with Python, is that other languages are faster than Python. Like Java, C, C++, pick any language that people generally say it's faster than Python. And yes, the answer, Python is slower. And the reason it's slower is because of what we said being the interpretation step, right? Whenever you have this compilation step in languages, when you write code, it gets compiled and then you run it, you optimize a lot in this compilation step. So the runtime becomes much faster. But because in Python, you don't have this compilation, you write code and you directly run it, your computer doesn't have time to optimize it. So because it's not optimized, it can be a little slower compared to optimized code, which you write in Java, C, or C++. So that's why Python, on average, tends to be slower compared to Java, C, or C++. But is that slowness noticeable, right? Is that slowness important? Is something you have to ask yourself. for most applications, the difference in performance of the latency is really small, so it may not really matter. But for some applications, if it does, then you probably would have to pick one of the faster languages, right? So that's why if you're building, let's say, an application to do stock trading, right? So stock trading has to happen like in milliseconds or probably even less than that. So there, because everything has to be that fast, although you could use Python, you generally see more C or C++ code written for those sort of systems because they tend to be really, really fast, right? So depending on your application, you may or may not be able to use Python in that sense. But in most cases, Python, at least for on average, is comparable. And you have special versions of Python. So there is a version of Python called Cython with a C. So this is Python that is written in C. So it tends to be as close to C as possible. So you could, it's still Python, but it runs as if it's like C. So there you could get a little more performance there. So you have some ways in which you could make Python a little faster, but on average, Python is going to be slower compared to Java or C++. Okay, so that's something to keep in mind. And finally, because of what we sort of talked about with the backwards compatibility, because Java generally tends to have this long-term support, a lot of a lot of companies prefer Java if they are looking for like huge projects or projects that are going to be there for like several years or decades. So Java could be the choice that companies go with. On the other hand, you have Python, especially for those cases where, because Python is so easy to get started with, right? So if you want to like quickly build an application and quickly put it out into production for the world to use, then Python is probably like the choice to go with. And you could still have long-term applications with Python, but Java is probably a little more favored in that aspect. All right. So this is how sort of Python stacks up with Java, which is one of the more popular languages there. You could sort of think of this as C versus Python, C++ versus Python. All of them roughly boil down to very similar exercises. All right. Okay, so we're not going to talk about this just as much, but just for those who are familiar, maybe you can understand what this does. Who, for those who are not familiar, I want you to see what a typical Python code looks like. So take a look at this. Hopefully, you can appreciate that this looks very much like English, right? The way you would maybe talk, it's not too far away from the way we write code here. So I'll give maybe a minute, try to take a look at that and see. I mean, if you can guess what the program is, I mean, I actually have the name already, but maybe take a minute to sort of like understand how Python code would look like. And in just a couple of classes that we do, you should be able to actually understand this code and write something like this yourself. All right. Okay, yeah, we'll maybe take a minute, so go through that. Okay. All right. So hopefully you at least got a sense of what it looks like. And yeah, again, at least things like for word in words or F word in counts. I hope it sort of looked a little like English the way we would normally talk, right? And we will see that being the theme in general in Python. A lot of times, even if you cannot understand exactly what's happening, you can still read the code like if it is if it is English. So that again is one of the reasons Python is sort of like easier to pick up when you get started. All right. So we'll go past this. So let's look at a couple of examples of what we were talking about, right? So we said Java is a little more verbose than Python. What we mean by that is you have to write more code for the same thing. So this is an example. So is the font all right for everyone? Shall we zoom in a little more, or is this okay? I hope you have a way of interacting.
Looks good.
Looks good. Okay, yeah. All right, so I'll just zoom in so we have a little more space here. Yeah, so this is basically like one of the more easier examples to sort of compare Java and Python. So Python, let's say all you want to do is display something called as hello world, right? You're printing it on your screen. So the code to do that is just this. You want to print something, you say print whatever you want to print. That's it, right? So Python keeps it simple. If you want to do the same thing in Java, right? Again, if you're familiar with Java, you know, otherwise you can skip this. It would look something like this, right? So compare this single line, smaller succinct code with this multiple lines of code that we have in Java, right? So this is what we mean by Python being short and compact, right? So a lot of other languages you need to do this because I mean, all you want to do is print hello world. Even in Java, what is class, right? What is main? So these things you have to do before you could actually write hello world on your screen. But Python doesn't care. You just start with print, right? That's it. So this is something again you would see a lot in Python. If you want to do something, more likely there is like a single line way to do that. And you know, that's how you would want to sort of like build your Python understanding as well. It's very rare where you will see like, you know, huge lines of code just to do something simple in Python. Usually a lot of things can be done, you know, very short in Python. Okay. So just so you have maybe a sort of like a blueprint that we use as we go through this course. So these are some of the topics that we are going to cover. So we'll start with introduction. So this is what we'll start with right after this. So we use something called as flow control. Then we'll talk about some of the data types that we have in Python. That is, how do you work with data, right? Because programs that do not have data are not really useful. Right? Any application has to have some data at the end. Right? I mean, think of it as you're using YouTube, for example. The data is the user information, the video information, things like that. And similarly, if it's Instagram, the data is the pictures that you're uploading. So any application needs to have some data. An application without the data is not really useful. So your program has to have some way of handling data. So we'll sort of talk about how you can save data, store data, and all of that. And we'll use functions. We'll talk about some of the object-oriented concepts in Python, and also a little more advanced topics depending on, you know, like the basis that we would have set by then. Right? So this is the general direction that we will go towards. But obviously each of them we can definitely play around depending on the requirements and, you know, the kind of examples that we will work with. All right. So this is like the set of things that we're going to talk about. And finally, before we get to that, I want to make sure everyone has Python installed on their laptop. So yeah, again, a little poll for the audience. I think a couple of you said you are familiar with Python, right? So for others and even for you, do you have Python installed on your computer right now? Do you know if you have Python installed, first of all? Okay, we have one yes. What about others? So if you have Python installed, that's good. Any version of Python that you have in the last couple of years would work for our use cases here. So the latest version of Python is 3.12, right? But anything beyond 3.9 is fine. So 3.9, 3.10, 3.11, 3.12, any of those versions would be same for our purpose. Okay, yeah, most of you are saying you don't have it. All right, so maybe we'll just spend 1 second or maybe 1 minute just so you know how to get it. I hope you could install it right away as we speak. So, all right, so yeah, for others who don't have, let's sort of talk about that in just a bit. So yeah, if you have Python, the way you know if you have Python or not is you open up a terminal, and I hope everyone knows what a terminal is, right? So you open up a terminal and just type in Python and press enter. So if you see something like this, the output, some version of this, then you have Python installed. If you don't, then obviously that means we have to install Python. So I'll show this on my computer just so you know what that looks like. Too many windows over here. All right. So let me open up my terminal and we can show from there. So I'll switch sharing to my terminal. And maybe just to get a sense, what operating systems are you on? How many Windows, how many Mac operating systems here? Windows, all right. Okay. Anyone on a computer that's not Windows or Mac? Maybe that will be interesting to see. Does anyone have a Linux computer? Okay, we have a few Macs as well. All right. Yeah, I mean, so like we said before, Python is cross-platform, so the operating system doesn't really matter. But how you work with Python, that is what tool you would use, obviously would depend. So on Windows, depending on whether you have like the latest or maybe a little older, you may have something called as a command prompt, right? Or a terminal, like you can have either of them. On Mac, I think terminal comes by default. On Linux, if anyone has there as well, you have a terminal by default. So whichever one you have, whether it's command prompt on Windows or terminal on Windows or terminal on Mac, the way you check if you have Python installed. So this is my terminal here on Windows. So I mean, just open it up. It opens like this sort of like some sort of a colored screen. Just type in Python and enter. If you run this, if you get some sort of a message like this, again, the version could be anything, anything above 3.8, for example. If it is, then you're good, you're set for the classes. If you do not, that means you don't have Python installed, right? If you get some sort of an error, like, I mean, I'm just typing something random, but yeah, if it doesn't know what it is, it will say something like, it's not recognized or not found or some version of that. So if you get something like this, that means you have to install Python, all right? So for those who weren't sure, can you try this out right now and see if you have Python installed? So open up command prompt or terminal, whichever you have on your operating system, and type in Python and press enter and see what you have already installed. If anyone has it installed, can I get which version you have installed? For those, if you don't, let's talk about that in just a bit. So yeah, I don't see any answers here. Which versions of Python? I think at least one person said they have it installed, right? So which version of Python do you have installed? 3.9. Okay, perfect. Yeah, 3.9 works for us. Does anyone have anything older than 3.8? Okay, all right, yeah, it doesn't seem like it, but 3.9 is fine. Anyway, then we'll just install it. 3.9 is fine, 3.10, 3.11, 3.12, any of those versions, perfectly fine. I mean, technically, anything above 3.6 is also okay, but 3.6, 3.7, and even 3.8 is about to expire, like officially run out of support, so it's better not to use them. But at least technically, anything above 3.6 is okay for us. Okay, all right. So for those who do not have it installed, let's see how we can get it. Let me just switch back to the browser over here. Oh, by the way, for those who are wondering what this tool that I'm presenting here is, so this is called a Jupyter Notebook. So it's a quick way to sort of like we can use this as both slides and to run code as well. So this makes it easier for teaching. If anyone is familiar with it, you can go ahead and use that, but you don't need this. You can write it in your regular notepad as well. So that completely works also. But this makes it a little easier for me while teaching, so I can show like some sort of like written instruction, plus we can actually write code as well together. Okay, so yeah, if you don't have Python installed, this is the site to sort of always go to. Python.org is the official Python website. /downloads takes you to the latest download that is available. So this is what it is. So I'll put this link. Wait, do I have a way to share it with everyone? Yeah, I'll put this link in the chat just so anyone, if you want, you can just download it. So this is the place where you could download it from. So this is your standard installation on Windows. It would download your exe file. On Mac, I think it would be your DMG file, I guess, right? So depending on your operating system, you could straight away go ahead and run through the usual installation process. It would be really quick. In fact, just to try it out, I reinstalled Python yesterday, and it took me like 30 seconds to install. So if you want to try, go ahead and do that right away. So download Python and install it. So it would be some sort of an executable through which you could easily run the application. And that should install Python. And again, the way you know you have Python installed is when you can run that Python on your terminal and press enter. So if you see an output coming up, you know you have Python installed.
Yeah, so someone is asking, can we use Google Colab?
Yeah. So if you have Google Colab, sure, you could definitely use that. Make sure you have the right version of Python selected there. But yes, if you have Google Colab, definitely possible. And Google Colab is actually a version of what I am using as well. This is Jupyter, which is what Google Colab is also based on. So yeah, this is that's perfectly fine to use Colab. All right. So yeah, for others, you can definitely go ahead and try this. Go ahead and download Python, set it up. We can wait for a minute or two, just so everyone has this installed. So everything we do going forward would use this Python. Maybe one thing just to keep in mind, while if you are installing it, at least on Windows, there was an option to say add it to the path, PATH path. So make sure you select that. I don't know how it would be on Mac, but I'm guessing that option would exist there as well. So do select that when you are installing it. So it makes it easy for you. So you don't have to do anything additional after that. So you can straight away start using it if you have it. So yeah, is anyone installing it or installed right now? And yeah, make sure you're looking at the current version. The version is 3.12. Okay. And it also gives you details about the previous versions. So you can see 3.13. Yeah, someone saying Python 3. Yeah, that's so yeah, maybe let me quickly show that just in case someone had any issues there. So yeah, good correction there, Krishna. So in some cases, it's possible that you may not have Python installed as Python. Like maybe if you just type Python, maybe it will give you an error, but it's possible it's actually installed as Python 3. So try that as well and see what you get. Okay. So in my case, Python 3 is not there, so it's installed as Python, but it's possible you may have it installed as Python 3. So see if that's something that's there. So in either of the cases, if you have, then you're good to go. If you don't have both of them, then we can, like, we'll have, we can look at, and you can just do Python 3 tab. Like that should definitely usually give you something. If either of them do not work, then that means you don't have it installed. Yeah. So thanks for that connection there. Yeah. All right. Yeah. Is anyone getting it installed right now? All right. So if you are installing and if it's done, let us know so we can maybe get started and proceed further. All right. Oh, not able to download. Oh, okay. I mean, is there a problem with download, or so this should straight away like take you to the download page. Yeah, I mean, it's downloading an exe file for me straight away. What's the issue you're facing there, Surekha? You can unmute and talk if that's a little faster.
Hi, yeah,
Mhm.
right now I am able to download it.
Okay.
But in the terminal, I mean, actually, this is a new laptop. I never
Mhm.
used terminal here. So when I actually opened it, it is saying set up Linux or SSH. It is asking like that. What should I do?
Okay, so which operating system is this? Windows or Mac?
Windows. Windows.
Windows. Uh, so can you try maybe with command prompt then? So I mean, I'm not sure what. So which terminal did you open up?
It just said terminal. That's it.
Okay, it's probably
Uh,
something that is installed by some other application maybe, because yeah, I mean, like the default terminal shouldn't ask you anything about SSH. It may be something that actually is a remote terminal there. But yeah, maybe what you could do is look for command prompt, see if that is installed there.
no.
So command prompt would be something that's generally always installed in Windows. So open up command prompt and again, same thing there, type in Python, and if it is installed, you should be able to see that.
Okay, I just realized that I'm just using Google Chromebook from my kids, so
Oh,
maybe that's
I
why
see.
I'm not
Okay,
able
okay.
to download
Yeah,
here right
yeah. If
now.
it's a Chromebook, yeah, it's a Chrome OS. Yeah, you wouldn't have a terminal there. I don't know if you can install an app for the terminal. I'm not sure, but yeah, maybe for those who are unable to install for whatever reason, right? Although not like maybe a replacement for having it locally, but there are a lot of Python IDEs online. So if I can just search up Python IDE, right? Uh, the, they're not, let's say, online IDE. Yeah, so you could use one of these. So let's say Python Fiddle is a popular one, or even online Python. You could use one of these and write Python code here, and you can run that here. So like for example, they have one some code written here, and you can actually like interact with the code and type in. So this could be a way which you could try. Again, if do this only if you couldn't install it through the other way, because that's like better in terms of your experience with Python, because this generally tends to be slower, and also like you wouldn't be able to save things like all at one place. You'd have to keep downloading it locally sometimes. So it's better if you can install it locally. But if you cannot, like the way Surekha had this problem there, so you can try something like this, Surekha. Like there are a lot of online IDs. Again, you can pick any of these, anything that looks good, right? So you can just pick the right code there and you can run it, and that can be maybe a way in which you could sort of like work with it. Okay, so you can try that as well. Maybe I'll just put this here. So this is not something I have used, but I've heard a lot of good things about this. So see if this works for anybody. So I'm just putting the link here in the chat if you want to try that. But yeah, I would prefer if you have it locally installed, so that will be better. Yeah, someone saying Jupyter. Yeah, so Jupyter, if you have it, perfect, that works as well, which is what I have here. All right, so what about others
So
still downloading?
right now I'm able to whatever you said, online Python IDE.
Yep.
I'm able to view it. Yeah, thank you. Thanks for the help.
Yep. All right. Yeah, that would work. Yes. But yeah, interesting that I wasn't expecting somebody to on a Chromebook. So yeah, you learn something new every day. All right.
Yeah, sorry for that.
No, that's
My
fine. I mean, like
laptop
it's
had
good to
a
see
battery
all
issue,
of it.
so
Yeah. In fact, so Chromebook is Chrome OS, right? It's built on top of your regular Android and web operating system. It's pretty much
yeah.
like a browser, pretty much. So there are versions of Python that can run in the browser. So in browser, people think JavaScript, right? But there is a version of Python that could run. So technically, you could write a Python application and run it on Chrome OS if we ever get to that place. But at least to start, I think you could use one of these web IDEs. All right. Yeah, maybe one last minute before we sort of move on. Anyone else having maybe any issues? Are we good to sort of get started? Again, the way you check if you have Python installed after downloading it is by typing in Python or Python 3. If either of those work for you, then you have Python installed. Okay. So we have only 3 people that said yes or no. What about others? Are you still downloading it or do you already have it? Okay. All right. Maybe we'll go ahead then. Yeah, maybe one last check. Any questions? I mean, anything that we should wait for? Okay. Yeah, Google Colab's fine. So that's all right. I'm maybe looking at others who haven't said one or the other. So if you have Google Colab, Jupyter, or an online IDE, you definitely can use them. Otherwise, a local installation is always good as well. You have this, and again, when we share this, let me maybe get back to full screen so we can save up some real estate here. Yeah. So when we share these notes, you will have this link with you again. So if you want to try it out later or maybe on a different computer, you can do that. Okay. All right. So a couple of things I want to make sure we sort of talk about Python before we actually get into the core of Python. So first thing, this is why things like Jupyter exist. What we mean by that is, in Python, right, everything is an expression. So in programming, you have two kinds of two kinds of things. So one is an expression, another is a statement. Okay, so you have statements and expressions. So statements are something that can do something like it's like something like 1 plus 2. But if it's a statement, you cannot use that value unless you store that in something, right? What we mean by that is, let's say I have 1 plus 2 over here, but if I want to get that value, I cannot just use 1 plus 2. I would have to save it in something. So maybe I'll save it in something called as A. Then I can use A because now A has the value of 3, and now I can do whatever I want with that, right? But if it is just 1 plus 2, I cannot do anything, right? If it's a statement. But when we say something is an expression, it means it not only calculates that, but gives it back to you, right? So that's the reason. So in Python, everything is an expression, meaning it's not just a value of its own. It calculates that, but gives it back to you. When we say gives it back, you don't actually have to store it in anything. You can see it's already printing 3 here, right? So that means it's giving it right away back to you. So if you try this in Java, you wouldn't get any value because it just calculates it and keeps it with it. That's the statement. So in Java, everything is a statement. But in Python, everything is an expression. So it calculates it and gives it back, right? So that's why in Java, you always have to do this whenever you want to like have some computation and save in something. But in Python, you don't have to. You can still do that in Python also. But because everything is an expression in Python, it's calculated and is also returned every time. Okay? So that's something to keep in mind. You will see that used quite a bit when we write programs. Another thing, so in programming, you always have this thing where you have to be careful with single quotes and double quotes, that whenever you're writing code. In other languages, that's definitely the case. C, C++, Java, single quote and double quote are completely different things, right? In Python, there is no difference. Whether you use a single quote or a double quote doesn't matter. It's up to your preference. I prefer single quotes because it's easier to type, right? Double quotes need you to press shift and double quote. But whatever looks good for you, you could use that. Single quotes and double quotes mean the exact same thing in Python. If you have background from other languages, this is something to get used to because in those languages, both of them are different. If you write something with a single quote, if you write something with double quotes, they mean something different. But in Python, they are exactly the same thing. Okay, so that's something to keep in mind. And yeah, so hello world here with single quotes or hello world with double quotes, both of them are exactly same. Okay, there is no difference. And another thing is Python is what we call as dynamically typed language. Okay, so again, in contrast, Java, C, C++, we call them statically typed. Now, what do we mean by that, right? So let's take again, like this is something we'll talk about again in a little bit, but let's see what we mean by it being dynamically typed and how it can be quite useful for us. So let's say I have this, so we call this as a variable. So variable is something where you can store some information, right? So A is a variable for us. You're essentially, you can think of variable as a box, right? So it's a box with something inside it and there is a name on the box. So that name on the box is A, and the thing inside it is 1, right? So that variable is like a box. So when we say A is 1, right? We know 1 is a number, right? Or more specifically, we call it an integer number. So that's why when I ask for the type of A, it says an integer, okay? And because it's a number, I could add another number, it gives me 3 and so on. But because I have started with A as a number, I am not forced to stick to that. If I now want A to be something else, right? Again, that something could be what we call as a string. Again, we'll come back to this in just a bit. But a string is basically a string of characters, right? Text. So if you have text, you can put that back into A. Now A is of type called string. String is basically nothing but text, right? So Python doesn't force you to stick to the type that you started with. We started with A being an integer, and then now I've put A as a text inside. So Python doesn't ask you to, you said it's a number, you have to say, you have to keep it as a number going forward. It doesn't care. So that's what we call as dynamic typing. in contrast, in Java, for example, C, C++, in a lot of other languages, if you, for whatever reason, started with A as a number, right? If you say A equals 1, you can never assign anything that's not a number. You can assign 2 to it, you can assign 20 to it because they're all numbers, but you cannot assign a text value to it, right? So in Java, the type is enforced. So type is basically what kind of data you're working with. So in our case, it's a number type. So anything you store in Java is strictly enforced. So that's what we call a statically typed. So if you put something as a number, it has to stay as a number. If you put something as a text, it has to stay as a text. You cannot go from one to another in Java. In Python, you have that flexibility. If you want to start with a number and then go to a text and then come back to number, you could do that. Python wouldn't stop you. Okay. So at any given point of time, as long as you know which type it is currently, you can write code and it would work fine. Okay. So that's something to keep in mind. We call Python dynamically typed languages, meaning the types are not checked. So Python doesn't care about the type that you are giving it. As long as you're doing something that works for that type, you are good to go. Okay. So that's something to keep in mind. It's a dynamically typed language. All right. With that, let's move on to one of the more controversial topics in Python, which is Python 2 versus Python 3. Okay. So remember the discussion we had just earlier about how Python 2 and Python 3 was like a huge change, right? So Python 3 was released back in 2008. Right? So like it's been quite a long time. But before this, Python 2 was what is there, right? Obviously 2 and then Python 3 came. So Python 2 was really popular. Right? That's when data science was getting started, numerical computation was getting started, machine learning was slowly also getting started in Python. So that was the time Python was being used quite a bit. So Python 2 was the sort of pretty much the most popular thing that everyone was using at that time. And then suddenly Python decided to release Python 3 because that's a new version of the language. And Python 3 was such a significant change compared to Python 3 that nothing you wrote in Python 2 would work in Python 3. Right? You have to rewrite everything to Python 3. It's kind of like, a whole new language almost. So it wasn't directly, you cannot take Python 2 code and run it with Python 3. It wasn't that simple. Somebody has to go in and change things to make it run with Python 3. And obviously, when that happens, people wouldn't like it, right? Because they have been writing code in Python 2 for all these years, and suddenly Python 3 came, and everyone, Python wants you to move to Python 3. So people weren't happy, so they stuck to Python 2. They weren't ready to go to Python 3 because Python 3 had a lot of changes, right? And people were sort of like sticking to Python 2. And this caused quite a lot of tension in the Python community because now you have these two camps forming where people are like Python 3 is better, I will only use Python 3. And this other group is like Python 2 is better and I'll only use Python 2. And whenever you have that, your entire community suffers, right? Because Python 2 and Python 3 are not compatible. People who are writing 2 in Python 2, people in Python 3 cannot use them. And same with Python 3. Python 3 was building new applications. People in Python 2 world cannot use them. So there was this sort of like a debate or struggle for quite a long time between which Python to use. And all this to say, although it doesn't exist right now, Python 2 has been officially retired in 2020. So you cannot use Python 2 anymore. But because Python 2 and Python 3 were both popular for so long, whenever you look up something online, right, and something we always do, so you type something on Google or Stack Overflow and you try to look up some answer for something, be careful which code that is, because Python 2 would not work on your Python 3 systems, and same, and vice versa. So if you ever see some code that is not working on your system, then it may not be your problem. It's probably because the code itself was Python 2. Okay, so that's something to keep in mind. The debate is now no longer there, so everyone has to use Python 3 now. So Python 2 has been done, but because Python 2 has been there for so long, there is a lot of code out there still in Python 2. Okay, so make sure whenever you are sort of like looking up code online or copying something, make sure you know which version that is. Okay, so yeah, that's something to keep in mind. And finally, a couple of things about syntax. Again, for those who are not familiar with what we mean by syntax, so syntax is basically how you write code, right? So you can think of it as grammar. So in English language or any other language, we have grammar, right, which defines the structure. Subject should come first, verb or object, depending on how your language works. It's the same way with syntax in programming as well, because you cannot just put in random words together and call it a program. It has to make sense, right? So that's what the syntax is for. So syntax orders your application, your code, so that your computer can understand what you're writing. So especially with syntax, in Python, we use white spaces a lot, right? For indentation, we'll again look at what that is. In other languages, white spaces do not mean anything. You can just put as many spaces as you want and everything is fine. But in Python, you have to be careful how many spaces you put in the beginning of lines. Okay, so that's something to keep in mind. And another thing is, in other languages, again, I'm comparing with Java, but could be C, C++, even JavaScript. We use a lot of semicolons, right? So whenever you say this line has finished, like the way we put full stops in sentences, in Python, we put, in other programming languages, you put a semicolon at the end to say this line is done and we're moving on to the next line, right? In Python, you don't need that. The moment you end a line, Python knows that the line has finished and it looks for the next line, okay? So these are the two things to keep in mind if you're coming from a different language, or if you, again, look at code from another language, all right? So these are the things to keep in mind. With that, let's move on to some core topics about Python. But yeah, maybe again, a quick pause. Any questions so far? The topics we've covered, have you been able to like appreciate Python, why we have to learn it, and how it sort of helps you with what you want to do? Any questions? I mean, about what we've talked about, or in general as well so far? Okay, all right, so looks like we're all good. So let's get started then with the next module here. So again, I'll make sure you have access to all of this. So each of these would be essentially a PDF file that you can get, and you can go through what we have covered in class, and like any code that we do, you can try it out as examples as well. All right, so let's get started with writing our first Python program, if you haven't done that already. So it's a convention pretty much in every programming language these days that whenever you start programming, the first program you should write is Hello World, right? So again, this is something that came with C programming. So C programming, like we said, is one of the most influential languages. So this came back in like 70s and 80s. So every modern language takes inspiration from Python or outright copies from C, right? So C was that popular. Before you have Java, Python. Imagine like as popular Java, Python, or JavaScript are today, the combined popularity of all of them was C at that time. It's that influential back in those days because everybody was using C, and everyone who created programming languages after were inspired by C. So a lot of things sort of followed from that. So, and that's why Hello World sort of became a convention, because the creator of C used to like show how you write code in C by writing Hello World everywhere. So that's sort of how the convention started with this. So this is the way we sort of build our first application. So let's start with this. So if you have Python installed, or whether if you're doing it on Colab, then it's a little simpler there. But if you have Python installed on your application, open up any text editor you have. So on Windows, it could be Notepad, Notepad++. On Mac, I think it's called TextMate or something like that, right? So whatever Notepad editor you have, any text editor basically. So, and again, text editor is not your Microsoft Word, so that's not text. It's what we call as rich text, so it's different. So you want to have a text editor. So anything like Notepad, Windows, Mac, whatever you have, open that up and write this in it. Print hello world in quotes. Okay. So try this out. You can call the file name anything, something.py. So py is an extension for Python files. So the way you have .mp4 for videos, or .exe for executables, or .ppt for PowerPoint, right? So .py is Python. So anytime you see .py, it's a Python source code file. So create a file called something, we can call it hello world.py if you'd like. And inside that, write this single line, which is print hello world. Okay. Write this and save the file. And the way you run it is, again, I'll show this in just a bit. Can I use Visual Studio Code? Yes, yeah, that's what I use as well. Yeah, you can use any text editor that you're comfortable with. Notepad was like, if you don't have anything else, but yeah, you could use VS Code, you can use IntelliJ, you could use Vim if you're familiar with that. There are countless options basically. Atom used to be quite popular back in the day. Just a couple of years ago, but now it's VS Code. So yeah, in fact, if you want a text editor of some sort, and if you don't have a preference, you can download VS Code. So it's publicly available. It's from Microsoft, but it's free to download and use. So VS Code is something you can try. That's what I am using here as well. All right. So yeah, let's switch to my desktop and we can try this out over here. All right, so I'll go back to my terminal. So yeah, I already have a program, I think, created. So I'll just open that. Hello. Yeah, so this is what we are looking for. So you have a file called hello world.py, and inside that, just put a line called print hello world with quotes. Right? So this is all you have to do to print something in Python. So start with this, save it, right? Once you have the file created, open your command prompt, terminal, whatever you have. Make sure you're in the same path where you have created that file. If you've created on your desktop, your downloads folder, wherever your folder you have created, make sure you are on that folder in the terminal. So you could find it in various ways. Here I can do pwd that tells me I am in this folder called Python beginner where my code actually is. So, and then you just run it with Python space the name of the file. So Python hello world.py, right? And again, like if you have Python 3 that is installed, so you could do Python 3 hello world.py. So whatever that is installed it as for you, and just run that. That should print hello world. Okay, so this would be our first Python program where we have printed something onto the display, which is our terminal screen. So yeah, I want to make sure everyone is doing this. So if you have installed Python, try it out. If you are doing it on Colab or one of those IDEs, you don't need to create the file, but at least directly run the code and make sure it's working for you. Okay, so yeah, I want to make sure everyone tried this and it's working for you, because yeah, you need a working environment for Python. So we'll maybe wait a couple of minutes. If you have any questions or if you are not able to get this running, let's talk about that. So for those trying online versions, Colab, Jupyter, or the online IDE we talked about, Are you able to get it running first?
What would be the path for that?
The path to the file?
Yes, it is online, right? How will it know where my file is?
Okay. Yeah. So when you're doing it online, I mean, if you're like, you're talking about Python editor like this, right? Here.
Yeah.
So if you're talking about an IDE, you don't have to know where it's saving. Like that's why you don't need the name of the file. It automatically runs basically. So whenever you run it, it is running whatever you give. So if I say print hello world over here, it directly runs that without you having to know which what file you are actually storing it as. But yeah, the only problem is it's going
Okay.
to take a while. But yeah, you can see it's
Okay.
printed. So here you don't need the file names if you are doing it online.
Okay, just directly run the command. That's it.
Yep, just run it directly, and that should give you the output hello world.
Okay. Okay, thank you.
All right, what about others? So do you have it running? Do you have it working? Has anyone encountered any problems? Perhaps if it's working good, did anyone have any issues getting it running? So yeah, this is the output you're supposed to see. Hello world being printed basically. Okay. All right. Perfect. No issues then. Anyone else will maybe spend one last minute to make sure if there are any issues, we can talk about that. But others, did everyone get it running? So this is how we would actually run all the future code. So make sure you have some way of running Python, and maybe just to sort of like make it easier, create a folder probably on your desktop or something, for all the lessons that we'll do, and you can keep running everything from there directly. Okay, so that
Quick,
would be easier.
quick question.
Yep.
What other applications we might need in the future apart from this Python, do you think?
Just to run like for Python, nothing else. Just the ability to have a text editor and a terminal is sufficient. But for future, we still don't need any tools, but we'll be installing a lot of libraries going forward.
Only the Python libraries, you mean?
Yes, only Python libraries. We're not using any additional tools for it. Just ability to write code and run it is sufficient.
Okay, got it. And I just wanted to understand if I can try it out any of the tools if we need the installation.
Yep.
Got it. Thank you.
Okay, yeah, maybe. So one thing again, not necessarily a recommendation because you could use whatever people are comfortable with. But yeah, the one idea that I was talking about, right? So if you want a way where it's a little easier to work with Python because everything is together, you can look at VS Code as an example. It's like your Notepad, but more suitable for writing code. So if you don't have a preference already of any editor, you can go ahead and try this Visual Studio Code. Again, I'll make sure you get access to the link. But yeah, it's not necessary, but it would be good to have if you would like to try it. So this is what
Yeah.
I'll be using for some of my code when we try. So that could be useful. What else? There is, I'm trying to remember what other popular, yeah, Notepad++ is another popular one as well. Yeah, this one. So either of them, again, like not a recommendation of any sort. I have used both. They're both perfectly good. So pick whatever works for you, whatever looks good to you. So these are options that you can definitely look at as a way. But a simple notepad is more than sufficient here. So every operating system comes with some sort of a notepad editor. So you could have something already here with whatever this is. But yeah, as long as you can write stuff here in a notepad, that's actually sufficient. But yeah, having some sort of a sophisticated editor makes it a little easier. So things
Yeah, I know. Basically, if you wanted to execute in the way you are writing the code, I think
yes.
that's useful for everyone.
Yep. That would be good. So yeah, you can definitely install that.
Got it.
All right. Yep. Good suggestion. All right. Anyone else? One last time. Any issues so far? All right. So we'll move on then. So this is the environment that we will be working with. I'll show one more way in which you could try. So again, like depending on which one you want to do, both will be perfectly good. So this is how we can sort of like run Python. Make sure your files have .py extension and you run them with Python or Python 3 space the name of the file that you have written the code in. This is how we sort of run it always. All right. Okay, let's come back over here. Yeah, and I mean, I hope you have already done this, but it's an exercise if you want to try, like, something else, like print whatever you want in the file and make sure it's running. Okay. But yeah, a couple of things to keep in mind is print, then you have these brackets and quotations. So the quotes are important because if you don't put quotes, again, single quotes, double quotes, both are fine. But if you don't have it, then you get an error. So make sure you have one of those quotes in the print statement. Okay, all right. So next thing we'll talk about is what's called as a REPL. Okay, so REPL stands for read, evaluate, print, loop. Okay, so it's an abbreviation for that. So remember previously, whenever I typed in Python or Python 3, pressed enter, it showed some output, right? That is actually how we get into the REPL. So REPL is basically a very quick way to run Python code without needing to do what we did earlier, where you don't have to like open up a file, save the file, run it with Python space. All of this is taken care for you. You just can directly start running Python code, right? The way we saw in the online IDE over here. So this is also a REPL. This is an online REPL. But whenever we typed in Python, and like this 3 arrows, whenever you see in Python, that's the REPL talking to you. So you can straight away start writing code in there, and that gets executed just like the way you did above. Okay. So if we switch back to my terminal here, so previously we had to do Python space hello world .py, but now I can just do Python enter, and that puts me in the REPL, right? So it's these 3 arrow, these 3 greater than symbols means I'm in the REPL, and you can see my cursor sort of blinking, right? So that means I'm in the REPL, and I can actually start typing Python code over here. So I can say hello, and that gets printed. Okay. So this again is a quicker way of doing the same thing that we have done. There are limitations to this, obviously, but if you want to try something like, you want to write like 4 or 5 lines of code and you want to see if it's working as you want, then a REPL is probably faster than having to like open up a file, typing it in, saving it, and doing it. Okay. So you have both options available on how you will write code as we go through these exercises. Okay. So you can type it out in the REPL, or you can try it out in a file and save it as well. One thing to note though is if you write in the REPL, you cannot save that code. If you want to keep track of the code you are writing and you want to go back and refer to it, you cannot do that in the REPL, because the moment I close the REPL, the code is gone. But if you save it in the file, obviously that file would exist. Okay. So this is called the REPL. So you can again try it out, with Python that you have installed. So type in Python enter, and you should be able to write any Python code directly over here. Once you get into this, The way you exit and the way you get out of the REPL is by two things. So one is you can just type in exit with brackets and press enter. So that is one way in which you could get out of the REPL. So you're back to the usual terminal. Or if I go back to the REPL once again, or you can press Control Z, that is, press enter. That also puts you out of the REPL. Okay. So either of them is a way in which you could get out of the REPL. So exit with brackets enter, or Control Z and enter. So both of them are ways in which you could get out of the REPL. So you can quickly type in Python, type some Python code, and then get out by by doing Control Z enter. Right. So that's what a REPL is for. So, and in fact, like the REPL is actually, you can see read, evaluate, print, loop. Right. It literally is what it does. So it's the R part of it is read. That is, it reads whatever the command you have typed. Then E, which is it evaluates it. So it runs the code, and then print whatever is the output, and then loop. That is, it loops back to waiting for you to read. That's why we call it a REPL. It's literally the job description of what a REPL does. Okay. All right. So let's get back here. So this is how we can sort of like, this is another way in which you can write code. So whenever you see these three symbols, right, that means you are in the REPL mode. So you can sort of start typing code. You do that, you get the output like this. All right. And yeah, the way you exit is by Control Z or exit and then enter. You get out of the REPL. All right. Now, yeah, again, try this out in the REPL if you have it installed. Open up the REPL, like print something on the REPL, make sure it's running as you're expecting it. Okay. So you would, even if you have text editors, right? Like, I mean, I have Jupyter over here, I have text editor, and we have online editors of our team that we use as well. But I still go to REPL quite a bit because a lot of times that's the fastest way to try some code without having to like be sort of bogged down by opening up an editor and running it, all of that. So REPL is a really good tool to have and get used to. So yeah, try this out and see if everything is working as expected. So now we're actually starting to get into Python itself. We're actually writing Python programs now. So we'll slowly ramp up. So obviously the initial ones are going to be simpler programs just to sort of get everyone acclimatized to that. But slowly we'll ramp up the pace and we'll do a little more complex exercises as well to sort of balance out what we'll talk about. Okay. The classes, as you can probably tell, are going to be interactive and also where you try out code in the class as well. So we'll discuss a topic. I'll show one example of code and I want you to try a different example and write the code yourself. And we'll have some home exercises, homework, if you will, that you can try out after the class to make sure you are you're still intact, everything that you have learned in the class, sort of like intact in that sense, right? So that's how we would want to make sure you are getting familiar with everything. So that's how we will have these classes as well. Okay, I don't see any questions or issues. So hopefully everything is working then with the REPL. So let's move on to the next step, which is taking input, right? So obviously, any programming language that can only print is going to be quite boring, right? You cannot do anything with that. You need to have some sort of an interactivity with the programming or with the language. And that's where inputting comes in. That is, you want to be able to take some input from the user and then do something with that, right? I mean, imagine like Facebook without the ability to take input. That is, you cannot upload images or you cannot log in, because there is no way for it to take anything. Then it wouldn't be Facebook, right? Because it would be just empty. So every application needs to have some way of handling input. So in Python, when you're writing code, the way you do that is by using input function. So get familiar with the word function if you have not heard of them. We'll keep using that quite a bit. Anytime you see these brackets, right, these parentheses next to something, that's the function. Okay, so remember that. So input is a function. Print that we saw before, which also has these two brackets around it, it's a function. Okay, so it means that it does something that you want. That's what the function term is. It has some functionality. Right? That's why we call it a function. Okay. So print functionality should be obvious. It prints something. Input functionality is to help you take some input from the user. Okay. So this is what we have now. So again, try this out as we do, whether it's in your IDE, whether it's in the Notepad or the REPL or the online IDE, wherever you're doing it. Make sure you have a way of running code. All right. So in Python, the way we take input from the user, right, is by using this input function. Okay. So that takes some input from the user, and what they give is obviously up to them. Right? You can ask whatever they should give, and they will give you that output, so that input. So you can say, for example, input, enter your name, meaning give me your name so that I can do something with that, right? So this is how we use the input function. So again, make sure you have these quotes around it, because we are giving text, or what we call as strings inside, and strings are always surrounded by quotes. Single, double quotes, doesn't matter. So you do this and we run it. So in Jupyter, I can quickly run it, but again, you run it the way we saw earlier, right? Whether it's in the REPL or if you write it in a file, then do Python space file name. So run the code and you will be prompted to type in something. So here you can see there is like a little box that popped up with a blinking cursor. So it's waiting for me to type something. So it says enter your name. I'll, for example, give name of Python's creator, Guido. So I type enter and we can see that has been received by the program. Okay. So this is how you can add interactivity to the application, where you can ask user to give something and you can use that information to sort of like do something in the program, right? You can think of this, we'll actually build that in the class, but imagine you are building like very simple calculator kind of application. You need to take numbers from the user, right? So what's your first number? What's the second number? What's the operation you want to do? So those things you have to get from the user, so that you can think of this as a way for you to get to that. So you use the input function, you put in some sort of a text, because user has to know what to give you, right? So this basically tells them what to give. So that's just like a hint to them, and then they'll give something that they would want to give for that. So this is how we do it. Okay. So you take input, some text, and that gives whatever has been typed by the user. It gives it back to the program, so the program can do something with that. Here, we're not really doing anything with that yet, but we could slowly start adding that in, adding those into. So yeah, the next step is, here we see whatever we have received, right? It just gets printed over here. So this is again the part of the expression we talked about, right? So in Python, everything is an expression, meaning it not only does something, but it returns it to you. It gives it back to you. And that's why, like when it's given to my Jupyter notebook over here, it just prints it by default. But because it's giving it back to you, you could actually put it into a variable. That is, you could name it something. You could store it in something. So that's what I'm doing here. So whatever is the name that comes, that is whatever is the name that the user types in and gives it to us, that can be stored into this variable. So variable, again, if you're not familiar, is just a box, right? So a box with some content is a variable, and that box has a label, right? It's kind of like your, I don't know how many of you do this as a general thing, but probably as a kid, if you have this lunchbox sort of setting, you would write your name on top of it, right? So that no one else can take it. You can sort of imagine that a variable is kind of like that. It's a box with a name on top of it. It has something inside, right? So whatever is inside that is the value of that variable. The label on top of that box is the name of the variable, right? So in this case, the name of the variable, we're calling it as the name itself. So name is the name of the variable, and whatever is entered by the user, that would be the input. So that gets stored inside the name. Okay. So here again, like if I run this once again, I'll give some name, for example, and I press enter. That gets saved into the name. So now name has some value in it, and that's what I'm printing, and that gets printed over here. Okay. So this is how we can take some input and save it into a variable. Okay. So now we have captured that value, so we can do something with that for the future. Okay. So this is how we take that. And yeah, one thing to remember is whatever you do a type, right? So type is basically how you can find out the type of whatever the value is. So if it's a number or a string, right? So string means it's a text type. If it's a number, it means it's a numerical thing, right? Like 1, 2, 3, so on. That would be a number. So imagine, see this, right? So if whenever I typed in, we'll skip this for now just a bit. But my name here is DSP that I've put here, which is obviously a string, right? So that's why when I do type of name, I get str, meaning it's a string. But imagine if I enter a number, right? So imagine I'm giving an age, so it's asking for age. I mean, let's say I'm the oldest person out there. I'll say my age is 500. Okay. And then I press enter, right? So I'm giving the age back to the program. So, but if you see, when we say type of age, it still says str, right? It still says it's a string. But what we have given is a number, right? What we have given is 500, which is obviously a number, but Python is saying that's a string. So this is where what we call as type conversion comes into picture. So what's happening here is that by default, whenever you enter something, even if you enter a number, Python thinks everything is a string, right? So even if it's a number, it thinks it's a character 5, not the number 5, but 5, the way it interprets it as 500 in quotation, right? So it thinks of it as an alphanumeric sequence. It just happens to be 500, but it thinks it's a string, right? But we know it's a number. So to make sure Python also knows that it's a number, we do something called as a type conversion. That is, you are telling Python, you are wrong. It's not a number. It's not a text. It actually has to be an integer or a number. So you ask Python to convert into a number. And the way you ask it to convert is by saying int and then the name of the variable you have given. So int of age. I mean, this was like the previous time I've run it. So if I run it now, you get 500. So now it has been converted into a number. Okay. So whenever you do something with an input, by default, I think we're over time, right? Yeah, we'll maybe pause here for the day. So if there are any questions, we can spend a couple of minutes discussing that. But yeah, this is sort of how we'll sort of continue. We'll pick it up from in tomorrow's class from here. We'll do a little more exercises. And again, for those who don't have a working system today, make sure you have it before tomorrow. You can get everything working by then. Make sure you install Python or have some way of running your programs. Okay. All right. So yeah, that's where we'll pause for today. We'll make sure all of the notes from today are available for you. You can try the code samples we have done, and we'll sort of make sure these are all available to you. Okay. Any questions, by the way? Anything we have covered so far? Anything about the topics we have talked about, or anything about the future lessons as well? We can discuss that today. So maybe let me ask a question and we can see what the overall audience poll is. What's the pace like? Are we going okay? Should we go faster? Shall we go slower? How should we do that? Or do you prefer the pace as it is?
At least people with more, programming experience, this could be good, or maybe little faster is also fine.
Yeah.
Need to see how others feel who are trying to learn the Python first time or not having any programming experience.
Yeah. Yeah, we have a couple of we have like a mix of audience here. So yeah, that's why we're trying to keep at least the entry a little easier to start. But yeah, once we get everyone on the same page, we can sort of like slowly ramp up the pace. But yeah, all right, yeah, good. What about others? Maybe especially for those who are beginners, right? Like maybe you're not familiar with Python before. What do you think? Like, is the pace okay for you? How do you see this going forward?
I have a PLSQL background, but Python is new to me. But this is all variables, integers, types, everything. Data
Mhm.
types are all usual in every language, so this is
Yep.
okay. Maybe going forward, if it is new topics, then it may take little time to understand. But for today, it is good. It's normal. We can go a
Okay.
little faster, but because of the
Mhm.
topics are similar,
Yep.
yeah, that's my opinion.
Mhm. Yep. All right. Yep. Thank you. Yeah, your experience in PLSQ will definitely be useful because, I mean, the syntax would look different, but at the end of the day, they're all programming languages, right? You want to do something. So the background you have and the experience you have and the ability to think of a solution, right? That would definitely be the same here as well. It's just that you write it slightly differently. But yeah, we'll keep that in mind. What about others? Anyone else with some feedback? Again, if any questions as well of what we have covered in class? Okay. All right. Yeah. If there are no more questions, then yeah, this is where we'll stop for
Uh,
today. Yeah. Go on.
just one more question, Swaru. I did not attend the demo class, but I have viewed the demo session online. Uh,
Mhm.
is uh, is the Python like how it? I mean, how hard is it? Is it okay? I mean, is it doable? I mean, in the real time hands-on experience, when you go without any experience, uh,
Mhm.
and if anything new will take time to I really understand that, but
Yeah.
when you go into market, you will have to go with a little bit experience. uh,
Mhm.
you have to put some little experience and then go, right?
Yep.
So how I mean, how should I ask this? Like hands-on everyday practice, how it
Mhm.
works, how do you guide us, how do you take us, because it's only on the weekends, right? On the
Mhm.
weekdays, will you give assignments, or how it works?
Yeah. So, yeah, this is going to be maybe just like I'll break it down into a couple of questions. So, yeah, first thing is like the eventual goal of this batch is to basically make you proficient in machine learning and data science, right? To get there, obviously, we have to sort of like take everyone along the journey and sort of like make sure you're good with Python, make sure you are good with like various libraries that you have with Python, and then finally get into machine learning as well. So that's the path that we're going to follow. And for each of those, we'll make sure we talk about some theory in the class. But again, like it's all programming. So programming theory is also going to be like practice in a way. But we'll make sure we'll do assignments or simple exercises like the way we saw in the class. But there are going to be exercises that you take home too that you can try like the very next hour if you want, or maybe after a couple of days, depending on how you want to do. But every class, at the end of every class, you will have some sort of an assignment or some sort of uh, oops, someone's saying something. Yeah, but you'll have like assignments to take home to and work on. So that will definitely help you with that. And coming to machine learning, when we finally get there, we would actually do projects together that you could use as a way to sort of get to like more real world ish experience. I mean, like there is no equivalent to real world experience. You have to be working somewhere, but you can at least safely get there by doing enough projects and enough experience through that. So yeah, to answer all of that, yes, we will have a lot of assignments for you to work on, both in the class and after the class.
Yeah, Sureka. So to answer your question more, like okay, so you have like a PL SQL experience, that will really help for you. And we are here to help you in the what we are planning is in even in the weekdays. So we will conduct one or two sessions with other faculties or whoever have the proficient, right? We, if you have any questions or anything, right? So we will make sure we'll clear the questions, and we'll make sure you get understand the class and any programming or anything, right? So
Sure. And now when you show us the duration of the training, it stated like 100 hours, 80 hours, 65, like that, right? I mean, in number of weeks or months, how much it would be usually to finish this training, like 6 months, something?
yeah, that's what we are calculated based on weekend classes. So for example, Saturday and Sunday, right? So if you take the 3 hours, so I think it will get 6 months.
Okay, thank you.